Loops are used to make things happen more than once. In this video, I'll talk about for loops and while loops, and how you know when to use each one. This is the general structure of a while loop. When this runs, the condition is evaluated. If it's true, the stuff inside the loop happens. And then we go back to the top and evaluate the condition again. That continues until the condition evaluates to false, at which point execution continues beyond the end of the while loop. Let's run one example. I'm just going to be the machine. I'm going to execute one statement at a time and see what happens. This declares a variable named count and allocates enough space to hold an integer. And then we put a 0 there. So now the while loop starts. We check to see if count is less than 3. It is, so we do the stuff in the loop. First, we print out the value in count. Then, this assignment statement evaluates the right-hand side. Count is 0. Adding 1 gives us 1. And then we store it back into the variable on the left-hand side. That makes count get bigger by 1. Then we print out high. This curly bracket shows that we're at the end of the loop, so we go back up to the top. Count has a value of 1, which is less than 3, so we do the loop again. We print out the value in count, increment count to make it be 2, and print out high. Back to the top of the loop. Count is 2, which is still less than 3, so we do it again. Print out the value in count, make count get bigger by 1, and print out high. Now this time, when we go back to the top, we compare the value in count to 3. Since count is 3, count less than 3 evaluates to false. That stops the loop, and the next thing that executes is that we print out done. Two details to pay attention to. First, the condition is only checked when we go to the top of the loop. That means that if the condition is true, the entire body of the loop will run. There are a few general kinds of loops. When we're talking about while loops, most of the time we're building sentinel-controlled loops. These loops run until a particular condition is true, and when the loop starts, we don't know how many times it will run. Here's a good example of a sentinel-controlled loop. The rand function returns a real number between 0 and 1. When this loop starts, we have no idea how many times the loop will run before we get something greater than or equal to 0.8. Maybe that'll happen with the first random number we get. Or maybe it'll take us 50 passes before it's true. There are lots of times when we need sentinel-controlled loops. While we've seen the syntax of a while loop, they usually fit into a broader picture of code. Most of the time, there's some code that sets up the loop, a repeat condition to keep it going. Then we do some stuff, and then we prepare for the next pass through the loop. For example, this code prints out the odd numbers less than 20. It sets up the loop by making num contain a 1. The repeat condition is num less than 20. The stuff we want to do is print out num, and then adding 2 to num gets us ready for the next time. C has another loop construct called a for loop. It has the same functionality as a while loop, but it puts all of that loop control at the top. It's really just a mechanical rearrangement of the parts that we've talked about. Let's look at an example of that. Here's the while loop we just looked at. We can translate that into a for loop by putting the setup code here, the repeat condition here, the stuff we want to do here, and the prep for the next time through the loop here. This loop is not a sentinel-controlled loop. Every time it runs, it's going to do the stuff in the loop 10 times. That makes it a count-controlled loop. We should talk about those. A count-control loop stops when the loop has happened a specific number of times, and we know when the loop starts exactly how many times it will run. In general, for loops are preferred for count-controlled loops. One common count-controlled loop is one that walks through an array, doing something with each position in the array. When it starts, we know that it will run once for each position of the array, and that makes it count-controlled. Sometimes it's a little hard to see whether a loop is count-controlled or sentinel-controlled. For example, This loop has a counting variable I and is doing something to an array. That might make you think that it's count controlled. However, the loop is not going to go all the way through the array every time. It'll stop as soon as it sees a negative number in the array. Since the data in the array changes how many times the loop will run, that makes it a sentinel-controlled loop. We don't know how many times it will run when it starts. This loop has some other challenges that we need to pay attention to. Click on the next video to explore it some more.